Let's take a look at the outline on slide 67. We're going to talk about a combined approach for doing imputation and the final analysis step together, where we can do all three methods, 3-step, BCH, and 2-step. Just to remind you, we are now within the manual multi-step area, and we're looking at distal outcomes together with covariates that have missing data. And we looked at three alternatives first: ML and integration, base, and multiple imputation. And again, now we're going to combine this and do imputation together with all three methods. Slide 68 then is a brief discussion of the two stages. First stage, which is really first step, it's a measurement model analysis once again. It's just with the slight change that we save data that can be used by all three methods later on in the final step. And instead of steps, we talk about stages here. Stage B is then the combined imputation and final analysis. So the reason for doing that is that one key advantage is gained by keeping the number of data sets to a minimum, as you will see. Now, you can also imagine when you have imputation needs that you want to do the imputation in a separate step. Here you do it together with the final analysis, and if the imputation takes a long time and you want to do many final analyses, maybe you want to do the imputation and save the data so you can come back to the imputed data, don't have to redo that. Well, but you can do that saving of the imputations also within this stage B using save data and then set data type imputation. So I'll show that in the input. Now, multiple imputation can be skipped, of course, if you don't have very much missing data on the covariates, or replaced by integration or base. But we're assuming here that you have a real need for doing imputation. So here's an overall picture of the analysis stages for this combined approach. Stage A, the first step, is the measurement model analysis, and stage B is the final analysis with multiple imputation and full model analysis. So the input specifications then are that we have the use variables 1 through 6 for the latent class indicators. And that's what we use in a measurement model analysis. And those variables are then saved for a last stage analysis. And we have the auxiliary option for the final stage, which has the covariates and the distal outcomes on it. And then we request C-probs for which we use for 3-step. So we have the three class probabilities for the three classes, and the most likely class, the nominal variable that we abbreviate to N. And we ask for BCH weights for the BCH approach. So we get 3 weights here, 1 for each class. And we also ask for S values, saving the measurement model parameter estimates for the 2-step analysis in the final analysis. So in the stage B, then, you have the 3 approaches following the data imputation. In 3-step, we have use variables N, X1, X3, Y1, Y3, and use the logits from stage A, which you add manually then for the last stage. For BCH, you have a slightly different use variable list, only the X's and the Y's, and the extra information that BCH needs is put into the training option, weight 1 through weight 3, BCH in parentheses. For 2-step, the use variable list is still different. You have to mention the latent class indicator variables in addition to the X's and Y's, because they are given S values from stage A, manually added again. So for 3-step and 2-step, as usual, we have to manually add things for the last step. BCH is a little simpler. You don't have to add anything manually. All you have to do is type this. So BCH can be preferable from that point of view, although it has its shortcomings as well, as we will see. So there are pros and cons for all three methods. Turning to slide 70 then, let's take a look at the stage A, the measurement model. So we work with the original data set, distal.dat, and here are the names. And we have use variable list only the indicators. And the auxiliary variables are the x's and the y's. And what we do differently here is to save data. We save C probs and BCH weights, both of them, plus S values that are requested within the output command. As an aside, in this run, we need to reorder the classes because they come out in different order relative to other runs that we do to be able to compare the results easily. So we do an S values reordering of the classes. The second class in the run here should be the first, etc. So the save data information now is all of the latent class indicators, all of the x's and y's, the BCH weights, and the C probs, and the most likely class that's 3-stage needs. Slide 72, then you have stage B, the final step, and let's take 3-step first. So the data file is the stage A data that we created in the previous stage. And this is the names list that we just looked at. Use variable list, as we noted earlier, is x's and y's with a n added to it, the nominal n. And the categorical variables are y2 and y3. We don't refer to the binary x1 because it is not a dependent variable in the model later on here. So the use variable list here refers to the variables in the model command, as usual. Data imputation is, as we described it earlier, the names list shows all the variables that give information, that carry information used for the imputation, and imputation is only for x1 and x2, where x1 is binary. And we have request 100 data sets, and in this case thinning is only 10 as opposed to 100 before. It's probably sufficient. And here you can say that you want to save these imputed data if you want to, if you think you're going to do a lot of analysis, and if the imputation step took a long time, then it may be useful to save it. Otherwise, just do the imputation over and over again for every analysis variation that you want. So the analysis is a mixture model. Estimator MLR starts equals 0, as usual for the last step, and then C on X, Y on X, and no X part, because the X's no longer have missing data. And just like before for 3-step, we fix the loadits from the first stage to the same values as we've seen before. Slide 73, we do the same thing for the BCH method. So the data is the same. The use variable list is different. It's only the x's and the y's here. Categorical is the same as before. And now we add training, where we refer to the weights of the BCH. They're sitting up here in the names list. And the imputation is exactly the same as for 3-step. And the analysis is the same as well. Nothing really new there. So it's easy to switch from 3-step to BCH and also to 2-step. So in 2-step, we have, again, stage A data. The names list is the same. The use variable list changes. You have to remember to include the latent class indicators here, and they are declared as categorical. And the imputation is exactly the same as for 3-step and BCH. And on the next slide, we see the rest of the model. It's a mixture model, starts equals 0. And here's a little note. You can add B iterations increase the default for the imputation step if you want to. You do it here in the analysis. You could have done that also for BCH and 3-step. And the model is the same, C on X, Y on X, and no X part. And now what's different for 2-step is that we have these fixed thresholds, these measurement parameters that are key for 2-step analysis.